My name is Bedri Cetiner. I'm an associate professor in the EC department. The one that we put more effort on is the smart antenna project. And in the classical sense, smart antennas are actually multiple of dummy antennas used in conjunction with some smart algorithm. So that is categorized as smart antenna in the literature. When we say smart antenna, the smart antenna project we do is basically it's an antenna which is smart itself. The thing that I should emphasize about my research group is that we go from idea, design, fabrication, and test and characterization cycle.
Use this lab to design our antenna, and we use those computers to design software HFSS.
Basically, I designed this antenna in HFSS. We have a software called HFSS, which is High Frequency Structure Simulator. I designed this antenna.
Yeah, I generally doing simulations with software and getting some. If I get some good result, I just fabricate with prototyping.
We are at the Nano Micro Lab fabrication facility, which is located in the physics department building. It is the very first microfabrication lab at the Utah State University. So our antennas are smart due to the nano size devices that are integrated within the antenna. The micro components must be actually fabricated in a laboratory environment like this, which is a clean room environment. They are very little. They are for even a very small particle, like a dust particle, can harm.
I built basic prototype here at the LPKF laboratory that we have at USU, and I send this to a place where it can be integrated with MEMS. So I just do the basic design. I fabricate the prototype, which is ready for MEMS integration, and then I send it for further integration and characterization.
When I got it done, I measured the hardware measurement in here in this Utah State University lab, and then for MEMS integration, I sent it to Cornell University. Some of our team members are working there on the MEMS switches. So they integrated the MEMS switch there, and we have a chamber there because it's a little antenna and it's high frequency. We cannot measure it here in the chamber. We have the little chamber for 2 gigahertz here in Utah State, but we send it to Cornell University to get it done there.
Our major project has been funded by the Department of Justice. At the time of catastrophes such as September 11 or natural type of catastrophes, then this efficient use of bandwidth becomes even more important because the number of users trying to use that bandwidth basically makes a spike. We can accommodate more number of users for a given limited bandwidth. During September 11, for example, people couldn't communicate because you have a limited bandwidth, and then the number of users you can accommodate is limited. Therefore, some users are out of the band. They can communicate. Therefore, our smart antennas becomes indispensable in those types of situations. You can accommodate large number of users for a limited bandwidth. In our smart Wi-Fi project, we are emphasizing using Wi-Fi systems in an outdoor environment where you can create a city which is called smart city. Let's think about our city Logan here. We can use our antennas in an outdoor environment in the city where public safety, police department, fire department, medical people can use this smart Wi-Fi system to communicate together.